Hello. This episode is part of the Web Application Security Testing series. I'll be reading an article and going through some maps and other items. And I'm excited about this because it shows how I investigated the foundation, or I call it the kindergarten, of offensive web application security, black box testing. And it can introduce anyone else who's a freelancer and secretly self-taught in the field to see how if you approach the information in the knowledge base a certain way, you can map out some clarity for yourself. So let's get started. I'll show you perhaps the map, first of all, here of the article. We got the title here, Web App Bug Bounty Hunter. And we got offensive web application security black box testing. So the overall map is like this. I'm showing this visually for those tuned in through video. And then we'll be heading through it like this from IT specialization down to InfoSec, through how it goes into AppSec, Web AppSec, and how there's various communities around this. Oh my goodness, all these acronyms. Eventually you get to see how it's offensive black box testing. There's stages of this testing. So basically a map shows you how all these aspects interrelate. Because in IT you have InfoSec. In InfoSec you have AppSec. Within AppSec you have web application security. This is where Bitcoin comes in because we're talking about Bitcoin being ubiquitous and all the applications people use on, especially on their mobile phones, but also just to access the internet. It's quite significant. Let me just add something here. One of the lights went out, so I'm just turning it back on by doing that manually. And as you can see now, I have to... Okay, good. So, yeah, we'll have a lot of analog things like this because I'm the only one producing and managing the whole technical and everything to do with this podcast. So, continuing on now. So web application security testing, secure software development lifecycle, DevSecOps is in there, Part of what they do is, within software testing is the security testing there. We got vulnerability scans, security scan, pen test, risk assessment, ethical hacking. All these are different things. They do belong to the security domain though. Multidimensionally, I find this part interesting. So only on a map can you see that within all of this, there's something interesting between risk assessment, and the threat exploitation there, how the weakness, can turn into a vulnerability with a likelihood and an impact there. And we're working on the mitigations, which are the security controls. Bitcoin itself here is a type of control for certain other things just by being. And so you see how the structure of the article will be flowing from my specialization in IT with all these aspects here, just the kinds of testing, just in order to understand where one is in particular in security operations. So let's get started. I'll be referring to some other maps as well as we start rolling here. I'll turn myself on for a moment here visually as I switch over. Okay, I got it going. So here we go, up with the article. Here it is. Kindergarten of Offensive Web Application Security. Black Box Testing. An article published in Cyberpower Telenoia, my series on Medium. The following is a foundational introduction to the linguistic and telescopic mapping of the vastness of information technology narrowing towards web application security and within it, offensive black box testing. This is essential for fine-tuning the formation of increasingly precise questions in this specialization. Information technology and security. Information technology, IT, is a broad field that encompasses the use of computers, software, and networking technologies to manage and process data. Information security, InfoSec, is the practice of protecting digital information from unauthorized access, use, disclosure, disruption, modification, or destruction. Applications. In the context of computer science, the term application typically refers to a program or a set of programs that perform a specific function, such as word processing, photo editing, or web browsing. The term application is often used interchangeably with software or program and can refer to programs that run on a wide range of devices, including desktop and laptop computers, mobile phones, and tablets. The word application has been used in computing since at least the 1960s and has its roots in earlier usages of the term in other fields. The term was likely adopted in computing as a way to distinguish between programs that perform specific functions and the more general-purpose operating systems and utilities that form the foundation of a computing system. As computing has evolved, the term application has become increasingly associated with software that runs on end-user devices, as opposed to software that runs on servers or other back-end infrastructure. AppSec, application security, is a broader term that encompasses security considerations for all types of applications, including web, mobile, desktop, and cloud applications, among others. While web applications are a common focus of AppSec due to their prevalence and the nature of the web as a public-facing platform, AppSec covers all types of applications that require secure development, deployment, and maintenance. Web applications. A web application is a type of software application that is accessed through a web browser, typically using the HTTP or HTTPS protocol. Web applications are designed to provide a user interface and functionality that can be accessed and used over the internet, rather than requiring installation on a user's computer. Web applications can range from simple, single-page websites to complex, multi-page systems with dynamic content and extensive functionality. They are typically written in web programming languages such as HTML, CSS, and JavaScript, and often utilize server-side scripting languages such as PHP, Ruby, or Python to handle dynamic content and data. Why web applications? The term application almost refers to any computer program. Web applications are programs that, in this case, are available on the ClearNet, the main public infrastructure of the internet. They form the web that is called the World Wide Web, which is a system of interlinked hypertext documents accessed through the internet. Web applications are most vulnerable field because of their ubiquity and attack surface. Most businesses have their applications in this public sphere. Overall, IT provides the infrastructure for web applications, while InfoSec helps ensure the security of those applications. And AppSec is one of the categories of approach used to implement that security through testing as one of the phases. SSDLC. Implementing a proper, secure software development lifecycle is a process model used by organizations to build secure applications, which defines how to integrate security into the software development process. DevSecOps stands for Development, Security, and Operations. It's an approach to culture, automation, and platform design that integrates security as a shared responsibility throughout the entire IT lifecycle. Security testing. This is a type of software testing that uncovers vulnerabilities, threats, risks, in a software application and prevents malicious attacks from intruders. The purpose of security tests is to identify all possible loopholes and weaknesses of the software system, which might result in a loss of information, revenue, reputation, and at the hands of the employees or outsiders of the organization. From the main types of security testing, as per open source security testing methodology manual, we have vulnerability scanning, scan a system against known vulnerability signatures. Security scanning. This involves identifying network and system weaknesses and later provides solutions for reducing these risks. Penetration testing. This kind of testing simulates an attack from a malicious hacker. Risk assessment. This testing involves analysis of security risks observed in the organization. Ethical hacking. The intent is to expose security flaws in the system. OWASP, the Open Web Application Security Project, is a worldwide free and open community focused on improving the security of web application software. The mission is to make application security visible so that people and organizations can make informed decisions about application security risks. OSINT, Open Source Intelligence. This is one way to gather information about a web application during the initial recon and enumeration phase, but it is not the only way. OSINT refers to the collection and analysis of publicly available information, such as information that can be found through search engines, social media, online forums, and other public sources. OSINT can be a valuable tool for gathering information about a web application, including information about the organization that owns the application, the technologies and frameworks used, the hosting environment, and potential vulnerabilities. Just want to get back to the map for a moment here and just show that we're talking about this OWASP section here with OSINT, and it's a part of the gentle entry through what this whole shenanigan is. Okay, back to it now. So, however, there are other ways to gather information about a web application as well, such as, I can show a map here while reading this. During the initial recon and enumeration phase, a tester may not have access to the source code or internal architecture of the application, and therefore relies on publicly available information to gather as much information as possible about the application's environment, its technologies, and potential vulnerabilities. Some common OSINT techniques that can be used in black box testing of web applications include searching for information about the target organization and its systems on public search engines, social media, and public records databases using tools like WHOIS, DNS lookups, and port scanning to gather information about the application's infrastructure, and examining the application's website and public-facing pages to gather information about its functionality, technologies, and potential vulnerabilities. By using these techniques, a tester can gain better understanding of the application and its environment and can identify potential attack vectors that can be further explored during the testing phase. So here we have METR, CWE, CVE, and CVSS, and OWASP, ASVS, WSTG, and cheat sheets. In the context of web application security testing, and I'll show the map here for a moment. So now we're talking about this area here. We're introducing some of the frameworks. In the context of web application security testing, the published security principles and guidelines from METR and OWASP are all recognized as authoritative resources that provide guidance and best practices for identifying, assessing, and mitigating vulnerabilities and threats in web applications. Each organization or hub has its own area of focus, whether it be identification and categorization of vulnerabilities, which is CWE, the assignment of unique identifiers to vulnerabilities, CVE, or the development of testing methodologies and frameworks, OWASP, WSTG, ASVS. Overall, these resources provide a comprehensive set of guidelines for understanding and addressing the complex landscape of web application security, and are an essential part of any effective security testing program. Request for comments, RFC. This is an additional part. This documentation can be a valuable resource in black box web application security testing, as it provides a standard for how different technologies and protocols should be implemented and used. RFCs can help security testers understand how a web application works and how data is transmitted. And what security mechanisms are in place. They can also provide guidance on how to test for vulnerabilities in a particular technology or protocol. One starting point for using RFC documentation in web application security testing is to review the relevant RFCs for the technologies and protocols used by the application, such as HTTP, SSL, TLS, and SMTP. The RFCs can be used to gain a deeper understanding of how the application communicates with clients and servers, and to identify potential vulnerabilities or misconfigurations. Additionally, RFC documentation can be used to develop test cases and scripts for testing the application, as well as to validate that the application is following the appropriate standards and best practices. Overall, RFCs can be a valuable resource for black box web application security testing and should be included as part of a comprehensive testing strategy. Black box versus white box. In web application security testing, the terms white box and black box are used to describe different approaches to testing the application. In white box testing, this approach involves testing the application with full knowledge of the internal workings of the application's code, including access to the source code. This testing can be more thorough and efficient than other approaches, as testers can identify specific areas of code and understand how different components of the application are integrated. This approach is typically used for applications that are developed in-house or where the source code is available to the tester. Black box testing. This approach involves testing the application with no knowledge of the internal workings, as if the tester were an external attacker with no knowledge of the application. Testers use techniques like input fuzzing, vulnerability scanning, and other methods to identify vulnerabilities in the application. This approach is typically used for third-party applications, where the tester has no access to the source code or internal documentation. Just a moment with the map here. Let's see where we are. Right, we're here. We're about to talk about DAST. So, dynamic application security testing, DAST, is a type of black box testing that involves scanning the application for vulnerabilities by sending input and monitoring the output. DAST tools simulate attacks on the application by sending a variety of inputs and checking the responses to identify vulnerabilities that can be exploited by attackers. This approach is useful for identifying vulnerabilities that might not be immediately obvious, such as those that only appear when specific inputs are provided. Web application security testing using DAST black box methods involves the use of various software tools to test a web application for vulnerabilities without knowledge of its internal workings. I would also add here, without reading, that manual DAST testing and stealth recon is something also that can be done in small steps, small, very tiny steps. Back to the article. This type of testing is designed to simulate an attack by a hacker who has no prior knowledge of the application, and it focuses on identifying potential security weaknesses in the application's inputs, outputs, and functionality. By identifying vulnerabilities through DAST testing, organizations can take steps to mitigate those risks and improve the security of their web applications. Offensive black box testing in SSDLC. Where are we here? Right here. Let's get back to it. This is offensive web application security testing, such as black box testing, can be integrated into various stages of the software development lifecycle, SDLC, not just functional integration testing. Depending on the organization's security maturity level, it could be integrated into the design, coding, testing, or deployment stages of the SDLC. One stage where black box testing can be integrated is during the functional testing stage, which typically occurs after the development stage and before the application is released to production. Other potential stages where black box testing can be integrated include the requirements gathering stage, development stage, deployment stage, maintenance stage. In general, offensive black box testing can be used at any stage of the SSDLC process where it can help to identify and address potential security vulnerabilities in the web application. Now, on to something a little bit different. We're going to see how weakness, vulnerability, threat, and risk all relate to this, and this is where we are on the map. In the context of web application security testing, the terms weakness, vulnerability, and threat are often used to describe different aspects of security risks. A weakness is a flaw or deficiency in a web application that could potentially be exploited to compromise its security. Weaknesses can be the result of programming errors, configuration mistakes, or other factors. A vulnerability is a specific instance of a weakness that can be exploited to compromise the security of a web application. Vulnerability attacks can take many forms, including code injection, cross-site scripting, and SQL injection. A threat is a potential attack origin acting on a web application that could exploit a vulnerability and cause harm to the application or its users. Threats can come from a variety of sources, including state actor, hackers, malicious insiders, and others. Now, risk in the context of a web application security testing is the possibility of a threat actor exploiting a vulnerability and is often measured in terms of the likelihood of an attack occurring, as well as the potential impact. Mitigation includes a variety of measures, such as vulnerability assessments, penetration testing, and other security controls. Vulnerability assessment versus penetration test. A vulnerability assessment and penetration test are both important components of offensive black box web application security testing. It is often said that vulnerability assessments are best done as white box tests, while penetration tests are best done as black box tests, because the two types of tests have different objectives and target different levels of the system. In a vulnerability assessment, the objective is to identify vulnerabilities in a system so that they can be fixed before they are exploited by attackers. A white box approach is often used where the tester has access to internal system details and is able to examine the source code, configuration files, and architecture. This allows for a more thorough analysis of the system and the identification of vulnerabilities that might not be detected in a black box test. On the other hand, in a penetration test, the objective is to simulate a real-world attack on the system in order to identify and exploit vulnerabilities and determine the effectiveness of the system's defenses. A black box approach is often used, where the tester has limited information about the system and must rely on reconnaissance and enumeration techniques to discover vulnerabilities. This more closely mimics the way an attacker would approach the system and can provide a more realistic assessment of the system's security posture. I forgot to put on my mustache. I'm going to do it now. Yeah. So, in practice, there is often overlap between the two types of tests, and the choice of approach will depend on the specific objectives and requirements of the test. For example, a vulnerability assessment might include some black box testing to identify vulnerabilities that are not apparent from the internal system details, while a penetration test might include some white box testing to identify the effectiveness of the system's defenses. Security testing rules. So just on the map here for a moment, I'm just going to talk about these little roles here. I have an article. Let's get back to the article. So hackers access a computer system or network without authorization. Crackers break into the systems to steal or destroy data. An ethical hacker performs most of the breaking activities, but with permission from the owner. Script kiddies or packet monkeys are inexperienced hackers with programming language skill. As an ethical hacker, both freelancing and working in-house as a web application security tester have their own advantages and disadvantages. Freelancing. As a freelancer, you have the flexibility to work with multiple companies and participate in multiple bug bounty programs simultaneously. You can choose the projects that you are interested in and work at your own pace. The income potential is often higher as you can set your own rates and take on as much work as you're capable of handling. Additionally, freelancing allows you to gain experience across a variety of industries and technologies. And these can help you develop a diverse range of skills. On the other hand, working in-house at a company can provide more job security and stability. You can also gain deeper knowledge and understanding of a specific application or product and have the opportunity to work more closely with the development and security teams. This can lead to opportunities for career advancement, including management positions and potentially more stability in terms of regular work and consistent salary. Ultimately, whether you choose to work as a freelancer or in-house will depend on your personal goals, preferences, and circumstances. So, with what I called here in the article some more precise text, a web app bug bounty hunter. Hunting for bugs means I look for weaknesses in web applications and disclose them as vulnerabilities to do the right thing and get remunerated with economic energy to live a balanced life. Offensive web app sec black box testing. From a generative AI text interaction. The term offensive web application security testing is not a commonly used term in the security industry. It is possible that it is used by some individuals or organizations to describe their approach to security testing, but it is not widely recognized as a standard term. The other terms, penetration testing, and ethical hacking, and red teaming, are more commonly used to describe the offensive approach to security testing. These terms generally refer to the practice of simulating attacks against a system or network in order to identify vulnerabilities and weaknesses that could be exploited by real attackers. Another note on ethical hacking. I help secure the right websites from the dark triad by using manual human knowledge mixed with generative machine learning algorithms to signal if a web application is vulnerable under the given context. It begins with an agreement of scope for black box recon and enumeration, stealth, followed by passive scanning and active attacks with report. The focus. I assist the right systems for the right people with the right technologies working for the right aims. The main field I work in is the coordinated transition to new, clean electrical energy sources beyond renewables. Ultimately, such energy sources are expected to be fuelless. Aside from several websites, I am available on freelancer portals such as Fiverr and answer questions on NOSTR, Stacker News, and Mastodon. I stand out by having particular areas of significant development which help identify me in this work. Some of those specializations include psychological and technological research into time, generative AI assistance, virtual reality, AR, MR enhancement. Let me show you what I mean by that, because in the next tab here, I had opened my lab on spatial, and it's available through your VR goggle headset. And I have various rooms there where I have placed my maps in virtual reality. And so you can zoom in on these texts and wander. And I would love to be collaborating on this. As you can see here. So this is a view just on the desktop, on the browser, not in four-dimensional space. But when you're there, you can obviously zoom in and even be able to move some of these maps and add your own to them. And so these kinds of solution rooms, I call them, would be especially for very complex security testing, especially of web applications and all the technologies that are involved in the architecture and infrastructure design. It is essential to have organized mappings when following a lead, when actually, I'll get into what attuned learning is, when you have a map and you resonate with it and you have new knowledge appear. So back to the list of specializations. Expanded states of experience, mesoteric attack vectors, deep web, clearnet, darknet, dark web, and secure personal communication. Public key cryptography. It may be significant and of value to anyone who understands this line of work to be able to communicate with me in a secure, private, and anonymous way. My public keys are uploaded to the top keyring servers with relevant subkeys for encrypting and signing interactions with various entities. Here's my primary public key fingerprint there, a NOSTR public key. In this way, for private consulting services, I may be contacted over decently encrypted communications. And that's it for this particular post, but in sense of the article, let's see back to the map for a moment here. I wanted to show a few more things. Yes, on this particular paper, I have placed, I'm showing this visually here, so tester domain dimensions. So here you may be able to see that, so within IT, so the aspects here in bold, security operations. Next line, we have application security. The next line, somewhere we have the test phase. Within that, we have the offensive aspects of particular web application, penetration testing and red teaming. And within that, we're working with the open source methodologies, in particular the OWASP and the black box manual DAST type of testing. And my specialization is information gathering and the stealth version of it. And within that, so how I see it, that within that is signal wizardry, I call it. Everyone has their own name for things once you really get into it. And then ultimately, like the deliverables are reports, and the reports of vulnerability assessments and bug bounty hunts. So, it is helpful to have even such a linear, almost like a waterfall effect mapping here. There's more words that I'm showing visually. That's one way of showing this map, which is a little different. It shows things not in a linear way. And I just read about all this, and you can see how these aspects relate just using keywords. And I wanted to show, again, as I did in my some of the previous article readings, is that in Paul Jeremy's security certification roadmap mapping, all these little boxes show various certifications that you can get in different realms and domains in even cybersecurity. And we are here in the rightmost, visually speaking here. And we're not on the defense side, which is all these blue certifications. We're on the offensive side. We have all these red certifications. And within just this domain, so you're not even talking about all these security aspects and domains. You can specialize in very particular things within penetration testing even. So exploitation itself and designing exploits, that is its own line of work. So that is enough. Oh, I didn't switch to that view. Well. Okay, well, I'll just show what I was talking about because I didn't switch to that view, and for the 100 or so viewers that will eventually watch this. So this was what I was talking about, the linear mapping of the aspects in bold. And this was the map I was talking about. That shows the mappings between the concepts a different way. And this is Paul Jeremy's map that shows all the domains and security certifications in the little bubbles. And on the right side is offensive and exploit development at the top here. Back to me here for a moment. I hope this episode provided some insight at the kindergarten level of web application security testing, going into RACON and vulnerability assessments and bug bounty hunting. On a personal note, I am concerned about the amount of people who, it seems to be young people, but also just people who hear about bug bounty hunting and they just read a few articles and they successfully start making hundreds of dollars just finding little security vulnerabilities in websites without knowing, without appreciating and respecting like the huge field of professionals, probably a few million people on the planet at it for decades now. And so I have found that it is possible to enter the field just by going on Medium and reading InfoSec bug bounty write-ups. But then you have no map of what you're involved in. And I come at it from caring and needing, because that helps me understand that there are the right entities to help secure their systems. Now, you might wonder why, and we'll get into that. It has to do with security culture and the culture of understanding that as a human being, you're choosing to work with computers. And what are computers doing in civilization right now? What time on the planet are you alive in? Can you see what's happening with the companies that are running IT? And can you see what is happening with the environment? What is happening on the planet? Why are wars happening? Does it involve you? Which companies are you supporting and why? And what are those companies doing to support you and life on Earth? I mean, this becomes quite significant when you get into it. It's basically the reason why Bitcoin exists and why the security of Bitcoin should be mapped. And this is why this podcast is called Bitcoin Security Maps. Oh, I love my my fake mustache. You guys who are tuned in just through audio, you should see my mustache on the recording here. So, because I do this with a sense of humor, hopefully, increasingly so. It's been quite a serious challenge to set up this podcast and just get a few of these episodes in. But this will get a lot of fun, and this will be big. I hope this episode showed some of that. If you enjoyed this podcast, feel free to offer support through various means, such as NOSTR or Fountain.fm, the app on Fountain. You can stream Satoshis through there every minute. And see you at the next meetups. That's all for now. I'm going to keep my stash for this one as we sign off here.